Welcome to 4.8, where we're going to talk about modeling with quadratic functions. So some of this might look familiar from 4.3 when we did some of this work, but we're going to expand based on some of the new information that we learned. So we are going to solve application problems using quadratic functions. Okay, a few reminders before we get started. Most of what we are going to see will be in standard form. So remember, standard form is y equals ax squared plus bx plus c. So when we talk about finding the different things, let's just refresh our memory on how we do that. So when we're finding the vertex, to find the x value, remember we take the opposite of b over 2a. And then to find the y value, we plug in whatever we get for x. Okay, we plug x into the equation that we started with to find their y value. To find the y-intercept, it's going to be 0 and a number, so we can either plug in 0 or know that when we plug in 0, all that's going to be left is c. So it's that c value. And what we're adding, what's new from before, is we can now find the x-intercepts. And we're going to solve for those using the quadratic formula. Trying to write and talk at the same time. So remember, that's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so again, there's just some reminders of once we get these equations, how we're going to find what we're looking for. Okay, so the first one, we're not going to apply any word problems, any scenarios. We're just going to practice, since it's been a little bit, finding these things. So find the following characteristics of the quadratic equation, round to 2 decimal places when necessary. My equation is h of t equals negative 16t squared plus 96t plus 4. So, let's start with the vertex. Okay, so again, to find the x value, I'm going to take the opposite of b, which would be negative 96, over 2a, which would be negative 16. And that gives me 3. Then to find my y value, I'm going to take and plug that in. So negative 16 times 3 squared plus 96 times 3 plus 4. And so y equals 148. So that means my vertex is 3, 148. All right, if I'm looking for the y-intercept, again, we can think of it as if we plug in 0 for x, but if we do that, this makes 0 and this makes 0, so all that I'm left with is 4. So it's going to be 0, 4. That's that c value at the end. Okay, and then lastly, for the x-intercepts, we are going to use the quadratic formula. So opposite of b would be negative 96 plus or minus the square root of 96 squared minus 4 times a, which is negative 16, times c, which is 4, all over 2 times a, again, which is negative 16. So that gets me negative 96 plus or minus the square root of 9,472 all over negative 32. And previously, we would have stopped there potentially, depending on what that radical ended up being, what was under the square root. But since these are application problems, we're going to just use the calculator to find the value of this. So I'm going to do negative 96 plus the square root of 9,472 divided by negative 32. And then I'm going to do negative 96 minus the square root of 9,472 divided by negative 32. In my calculator, I'm going to get x equals negative 0.04, or 6.04. So there's my two answers, my two x-intercepts. Okay, so what does this look like in a application problem? A baseball is hit so that its height above the ground is given by h of t equals negative 16t squared plus 96t plus 4, where h of t is the height in feet and t is the time in seconds after it's hit. Round to 2 decimal places when necessary. So first question says, how high above the ground was the ball when it made contact with the bat? So when it makes contact, that means the initial. So that's the y-intercept, right? When we plug in 0 for time. So we already learned that that was 0.4, which means that it was 4 feet above the ground. How long does it take the baseball to reach its maximum height? If you notice, this is the same equation that we dealt with last time. So now we just have to think about, what is it asking us? So again, anytime you see the word maximum, that's a clue that you're looking for the vertex. You're just deciding, is that the x value or the y value of the vertex? So in this case, that's the x value. So we would be doing the opposite of b over 2a, which would be negative 96 over 2 times negative 16, which you already figured out is 3. So it would take 3 seconds to get to its maximum height. Okay, and then what is the maximum height? That's the y value of the vertex. So we would plug this in. And again, we found this in the last problem, that is 148 feet. Last one, and again, this is the new part. Assuming the ball is not caught, how long does it take for the ball to hit the ground? So you can think of, here's my parabola. It's getting hit, and then it's coming back down. So this is what we're looking for, which is the x-intercept. Okay, and again, we find that by using the quadratic formula. So we did do that on the last slide, but just to refresh your memory, opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I'm not going to go through the math because, again, I just did that on the previous slide, but we got two values. One was negative 0.04, which we know that was before it got hit. So the answer has to be the second option, which was 6.04 seconds. So it reaches its maximum height at 3 seconds, and then it's back on the ground at 6.04 seconds. All right, let's do one more together. Number 3, a ball is tossed in the air, following the path given by the equation. H of t equals negative 16t squared plus 80t. So again, that's the equation that I need to use for this, where h of t is the height in feet and t is the time in seconds. What is the height of the ball after 3 seconds? So 3 seconds, that's our t value. So I'm just going to plug in negative 16 times 3 squared plus 80 times 3. So all I'm doing is plugging in t equals 3 and getting an answer of 96 feet. So after 3 seconds, the ball is 96 feet in the air. What is the maximum height the ball will reach? So again, when you see maximum, that's your clue that you're looking for the, whoops, wrong pen. You're looking for the vertex, and maximum height is the y, okay? In order to find that, we first have to find the x. So x equals the opposite of b, which would be negative 80 over 2a, which is negative 16. Plug that into your calculator, you should get 2.5. So it takes 2.5 seconds to get to its maximum height. To figure out what the maximum height is, we're going to plug in that 2.5. And again, this is just a calculator problem. We should get 100 feet. So 100 feet is its maximum height. Last part, how long does it take for the ball to reach the ground? So again, if it says reach the ground, what we're looking for there is the x-intercept. And we find the x-intercept by using the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, which in this case is 0 because there isn't a constant, okay? All over 2 times negative 16. There's just the a term and the b term, so c would be 0. And again, this just becomes a calculator problem. I end up getting negative 80 plus or minus 80 over negative 32. So negative 80 plus 80 is 0. 0 divided by 32 is negative, or is 0, right? So I'm going to do negative 80 minus 80 divided by negative 32, and that gives me my answer of 5 seconds. Okay, so it reaches the ground after 5 seconds of being in the air. All right, so we will look at some more examples like this in class, but that is 4.8.